So in the last lesson, we have learned that atoms have OCD and they need to have fully filled valence shells before they can be stable. Alright, so metal atoms, they tend to lose their valence electrons to form positively charged ions called cations. And non-metal atoms, they tend to gain electrons to form negatively charged ions called anions. Alright, so in this lesson, we're going to explore further what happens when a metal meets a non-metal. Alright, we have already learned that previously that the metal will tend to transfer its electrons to the non-metal, and this kind of bonding is called ionic bonding. Okay, so in the later slides, we're going to look at what is ionic bonding in greater detail. Now, there are three main things that we are going to learn. How is an ionic bond formed? What is it? And how can we represent ionic bonding? How can we represent ionic compounds? Okay, how is it formed? We have already briefly talked about in the previous lesson. So ionic bonding occurs when a metal atom meets a non-metal atom. Okay, we have learned that metal atom tends to lose electrons and non-metal atoms tend to gain electrons. So when a metal atom meets a non-metal atom, what happens is that the metal atom will transfer its valence electrons to the non-metal atom, and in the process of doing so, both will achieve noble gas electronic configuration, and this is how an ionic bond is formed. Okay, when the metal atom loses its valence electrons, it will form positively charged ions called cations, and when a non-metal atom gains electrons, it will form negatively charged ions called anions. Now, in science or in nature, whenever you have something that's positively charged and something that's negatively charged, there is some form of attraction. Alright, something like a magnet, north and south, they attract. So plus and minus, opposite charges, they also attract. And this form of attraction is given a special name. It's called electrostatic forces of attraction. Alright, so a cation, between a cation and anion, there's actually some form of attraction. We call this electrostatic forces of attraction, and this electrostatic force of attraction is essentially your ionic bond. Okay, by the word bonding, it means some form of attraction. Alright, so ionic bond is the attraction between plus on your cation and minus on your anion. Okay, so from this part, we have actually covered the first two questions. An ionic bond is formed when electrons are transferred from metal atom to non-metal atom, and in the process, both will achieve electronic configuration, noble gas electronic configuration. We have also answered question 2, what is an ionic bond? An ionic bond is the attraction, the electrostatic force of attraction between your cation and your anion. Okay, in the next few slides, we will look at the formal definition of ionic bonding and ionic bond. So as mentioned, how is an ionic bond formed? The keyword over here is the transfer of electrons from metal atom to non-metal atom. And why is there a transfer? Is because after that, both will actually gain achieve a noble gas electronic configuration and become stable. What is an ionic bond? Ionic bond is the electrostatic attraction or electrostatic forces of attraction between oppositely charged ions. Very quickly again, if you have a cation and if you have an anion, there's a plus charge and a minus charge. This plus charge will actually attract the minus charge. Okay, like charges repel, unlike charges attract. Okay, so this attraction is your ionic bond. Now take note that there is a slight difference between what is ionic bonding and what is an ionic bond. When we ask for what is ionic bonding, we are asking for the process, how is it formed. Right? When we ask you what is an ionic bond, we are asking for what is it. So is the bonding, is the attraction between your cation and anion. Now we move on to question number 3. How can we represent ionic compounds or ionic bonding? Okay, there are 3 ways we can represent an ionic compound by name, formula, or dot and cross diagram. We will look at each one, we will look at them one at a time. So now we will look at how we name an ionic compound, and before that, just try to recall that an ionic compound is formed between a metal and a non-metal. Right? When a metal combines with a non-metal to form a compound, the name of the compound, we will put the name of the metal first, followed by the non-metal. That's the first rule. Alright. Next thing, the metal will retain its name. The non-metal, we actually replace the last part of the name with IDE. Okay. So what do I mean by that? Let's look at an example. When sodium combines with chlorine, the compound that's formed, we will put the name of the metal first. Okay. We will replace the last part of the non-metal, the name of the non-metal, with IDE. So the compound form is called sodium chloride. Okay. Similarly, when magnesium combines with oxygen to form a compound, we'll write the name of the metal first, magnesium, and then we'll replace the last part of the name of the non-metal, right, with IDE. So the compound, the name of the compound is called magnesium oxide. Okay. Similarly, when aluminium forms a compound with sulfur, the compound is called aluminium, and then sulfur will replace the last part with IDE. So the compound is called aluminium sulfide. And last one, when potassium combines with fluorine, the name of the compound is called potassium fluoride. Okay. Now when we are looking at ionic compounds, sometimes the cation or the anion can be made up of more than one atom. Okay, so we call this ions polyatomic. Poly means more than one. Okay, atomic means atom. So if an ion has more than one atom in there, all right, we call it a polyatomic ion. Now we'll look at some examples. For polyatomic ions, there's no way you can infer the charge from the group number. All right, unlike a metal ion, we can actually tell the charge from the group number. Group 1 equals to plus, group 2 equals to 2 plus, and so on. But for polyatomic ions, there's no way you can infer the charge. You have to memorize the formula of the ion plus the charge. Okay, so these are the polyatomic ions that are in the syllabus. So please make an effort to go and memorize the formula and the charge. Carbonate has the formula CO3 2 minus. Hydroxide is OH minus. Nitrate, sulfate, and then ammonium. Okay. Now that we have seen the formula and the charges on the ions, I'll go on to further explain again why they are called polyatomic ions. Alright, let's use carbonate for an example. Carbonate is made up of 4 atoms. It's made up of 1 carbon atom and 3 oxygen atoms. And this whole particle over here has a charge of 2 minus. Okay, now how is this different from the anions that we have seen so far? For example, chloride. Chloride ion, the minus charge applies to only 1 atom. So we call this a monoatomic anion. Mono again means 1. Alright, However, if you look at carbonate, the 2 minus actually applies to the whole group of particles, of whole group of atoms over there. And the whole group of atoms is made up of 4 atoms in total, more than 1. So therefore, we call it a polyatomic. Poly again, more than 1, polyatomic anion. Okay, there's only one polyatomic cation in the syllabus, which is ammonium ion. Okay, so for ammonium ion, you can see that there's 1 N and 4 H atoms, and this whole unit, this whole group of atoms actually has a positive charge to it. Okay, so since there's more than 1 atom in this ion, we call it a polyatomic ion. Now that we have seen how we can name an ionic compound, let's look at how we can write the chemical formula of an ionic compound. Alright, so these are the 4 ionic compounds that we have seen so far. How do we write the formula? Firstly, we need to know the charge on each ion. Okay, so how do we know the charge? We have seen previously in the last lesson that we can actually infer the charge from the group number of the atom. Okay, for example, sodium chloride. Sodium chloride, from the name, we know that it's made from Na and Cl. Okay, in order to know the formula of the compound, we need to know the charge on sodium ion, and we need to know the charge on chloride ion. Okay, so sodium is actually found in group 1 of the periodic table, and chloride is found in group 7 of the periodic table. If you can recall group 1, yeah, let's do a quick revision. Group 1 atoms, alright, they tend to form ions of plus charge. Group 2, 2 plus, group 3, 3 plus. Group 4, they tend to form 4 minus. Okay, for non-metals, remember, it's 8 minus the group number. So group 5 will be 3 minus, 2 minus, and minus. Okay, given that sodium is in group 1 and chlorine is in group 7, sodium will have a charge of plus, chlorine will have a charge of minus. Okay, so in order to get the formula, you need to ask yourself, when you combine the 2 ions, do the charges cancel out? Alright, because only then will you get a neutral compound, only then will you get a stable compound. So the answer is yes. Alright, plus and minus, it actually cancels out. So this is the formula. This is the chemical formula for sodium chloride. Take note that in the writing of the formula of the compound, we no longer show the charges. The charges actually cancel out. Okay? Now second, let's look at the second ionic compound. We have magnesium chloride. We will know that it's made up of magnesium and chlorine. Now magnesium is in group 2, chlorine is in group 7. So once again, from the group number, we can infer that magnesium has a charge of 2 plus and chlorine has a charge of minus. Alright, so now if we combine Mg2 plus with Cl minus, do the charges actually cancel out? The answer is no. Alright, because 2 plus and a minus, does it equate to 0? Answer is no. Alright, so in this case, how do we obtain the formula of the compound? There are 2 ways. Right, the first way is to simply ask yourself, how many more of which ion do I need for the charges to be balanced out? And for those of you who can easily see that, you actually need just 1 more chloride ion. So 1 magnesium with 2 chloride ions, it will give you a neutral compound. The charges will cancel out. For those of you who cannot see that, there is a very popular method called the cross multiplication method. So you write out the 2 ions with their charges. Next, you write down the number on the charge. For example, magnesium Mg2 plus, the number is a 2. Cl minus, the number on the charge is a 1. Alright, and then you multiply each ion by the number that's opposite to it. So you cross multiply. Okay, so after cross multiplication, you will get a formula of MgCl2. Okay, so now we'll look at the third example, sodium oxide. Sodium oxide is made up of the metal sodium and the non-metal oxygen. Sodium is in group 1, oxygen is in group 6. From there we can infer the charges on the ions, and once again, combining Na plus and O2 minus, the charges do not cancel out. Alright, so if you want, you can do the cross multiplication technique again. Na plus, O2 minus. So we write down the number on the charge just below the ion. Na plus, the number is 1, O2 minus is 2, and then we multiply the ion by the number next to it. Okay, so in this case, the formula of sodium oxide is Na2O. Right, in the very last example, this is I would say the hardest amongst the four. We have aluminium oxide, which is formed from the metal aluminium and the non-metal oxygen. Aluminium is in group 3, oxygen is in group 6. So from there, we can tell the charges of aluminium and oxygen ions. Okay, so now when you have Al3 plus and O2 minus, it may not be easy for you to see how many of each ions do you need for the charges to balance out. So in this case, your cross multiplication will come in very handy. Okay, so for one last time, I have Al3 plus and O2 minus. We write down the number on the charge. Aluminum is 3, oxygen is 2, and then we multiply the ion by the number across it. Okay, so we need 2 aluminium and 3 oxygen. So the formula of aluminium oxide is Al2O3. Okay, so in order to find the formula of an ionic compound, we first need to know the charges on the ions. And once we know the charge, the trick is to make sure that the charges will cancel out when you combine the ions together. And the cross multiplication technique here will help you determine the number of cations and the number of anions that need to be combined. Other than name and chemical formula, there's one last method to represent ionic compounds, and it's by means of a diagram, or more specifically a dot and cross diagram. Okay, so we'll look at how to draw dot and cross diagram for 4 ionic compounds, but in general the approach is the same for any ionic compound. Okay, so let's take a look at the first one, sodium chloride. Now in drawing the dot and cross diagram for an ionic compound, the very first thing, or rather it will be very helpful if you can write out the electronic configuration of the ion. Alright, and in order to get the electronic configuration of the ion, it will be good if you start with the electronic configuration of the atoms that forms the ions. Alright, so sodium chloride is made up of sodium and chlorine. Sodium has the electronic configuration 281, chlorine has the configuration 287. Alright, so we have already learned the outermost shell is not fully filled, so they will tend to gain or lose electrons to make it fully filled, and sodium tends to lose 1 electron. When it loses 1 electron, it forms Na plus with the following electronic configuration 2.8. Chlorine tends to gain 1 electron to form Cl minus, and by doing so it will acquire an electronic configuration of 288. Okay, so to represent sodium chloride, we need to show how the electrons are arranged in the ions in a diagram form. Okay, so this is how we do it. Sodium ion has this particular arrangement of electrons, 2.8. Okay, it has a charge of plus. Chlorine has the following arrangement of electrons. I have 2, 8, and then 8 also. Okay, now take note that when I'm filling up the outermost shell, one of the electrons here is a cross. Now why is it a cross? Because this electron actually came from sodium. Okay, if you haven't noticed, I have used two different symbols to represent the electrons from the two different atoms. Alright, cross represents an electron from sodium, whereas dot represents electrons from chlorine. Okay, so as mentioned just now, one of the electron on your chlorine must actually be a cross. Okay, why must it be a cross? Because the electron was actually transferred from sodium to chlorine. Okay, so the diagram that you see here is a dot and cross diagram for the ionic compound sodium chloride. Okay, so using the same approach, I'm going to show you the dot and cross diagram for the next three compounds, and each time we'll get slightly faster and faster. Now we'll look at the ionic compound magnesium chloride. Magnesium chloride is formed from magnesium and oxygen. Magnesium and chlorine. So magnesium has the electronic configuration 282. Chlorine has the electronic configuration 287. From the electronic configuration, we know that they are not stable. Magnesium needs to lose 2 electrons to form 2.8. And then chlorine needs to gain 1 electron to form 2.8.8. Okay, so once again, in order to draw the dot and cross diagram for magnesium chloride, we need to show the arrangement of electrons in both ions. So magnesium, the arrangement of electrons looks like this, 2.8. And then there is a 2 plus charge. For chloride, we have 2.8.8. So I'm going to show the arrangement of electrons like this again. Okay, so that. Alright, once again, the legend is as follows. X represents electron from magnesium, whereas dot represents electron from chlorine. Now, there is still a part that is not complete. What is the part? The part is this. Now, you notice that magnesium actually lost 2 electrons, but chlorine only gained 1. So where did the missing electron go to? Right, you may wonder. Right, that means that actually you need more than 1 chloride ion to form the compound magnesium chloride. So in fact, if you use the cross multiplication technique, you would be able to know that the formula of magnesium chloride is MgCl2. So actually you need 2 chloride ions to pair with 1 magnesium ion. And do we need to draw another chloride ion? You can if you want, but an easier way is to put a big 2 in front of the chloride ion. So that tells us that you know that there are 2 chloride ions. Okay, bear in mind, do not put the 2 as a subscript. It doesn't work this way. Right, do not put the 2 as a subscript, put the 2 in front of your chloride ion. Next, we will look at sodium oxide. Sodium oxide is formed from the atoms sodium and oxygen. Sodium has a configuration of 281, oxygen 2.6. Sodium will lose 1 electron to form 2.8 and Na plus ion. Oxygen needs to gain 2 electrons to form 2.8 also, and O2 minus ion. Okay, so now we'll draw the dot and cross diagram for sodium oxide 2.8. Okay, and then oxide would be also 2.8. Now for this time, also bear in mind that oxygen has gained 2 electrons, so 2 of the electrons must be crosses. Okay, you may be wondering, do I need to pair up the electrons that are crosses, or can I split them up, put them on the left, right, top, bottom? It doesn't matter, as long as there are 2 outermost electrons that are crosses, that will do. Okay, cross stands for the electron from sodium, and dot stands for the electron from oxygen. Now the diagram is still not complete again. Sodium has lost 1 electron, oxygen needs to gain 2. That means that you actually need 2 sodium ions to supply the required number of electrons for oxygen. Okay, and again, I know I'm getting naggy. Please do not put the 2 as a subscript, but rather put it in front of the ion. Okay, now we'll look at the one last example of aluminium oxide. By now, I hope you have started to take note of the approach of drawing a dot and cross diagram for an ionic compound. Alright, so aluminium oxide is formed from the metal aluminium and the non-metal oxygen. Aluminium has an electronic configuration of 283 and oxygen is 2.6. Okay, aluminium will lose 3 electrons to form Al3 plus. Oxygen will gain 2 electrons to form the ion O2 minus. Okay, so to draw the dot and cross diagram, we need to represent the 2 ions, how the electrons are arranged in the 2 ions. Okay, aluminium would have a charge of 3 plus. Oxygen, now again, if you look at the above, oxygen has gained 2 electrons, so 2 of the electrons must be crosses. Okay, and then besides the legend, the very final thing now is to know how many oxygen ions will be paired with how many aluminium ions. And if you use the cross multiplication technique, you will know that there are 2 aluminium ions combined with 3 oxygen ions. Now, these are the common mistakes that students make when drawing dot and cross for ionic compounds. Alright, so the very common mistake is that there's no legend, so we don't know which symbol represents electrons from which ion. I know you can say that it's very obvious, but without the legend, we will still deduct marks. Okay, no legend. No charge, meaning, for example, on drawing the sodium ion, so you'll write 2, 8. Okay, some of you all would remember to put a bracket, but then you would forget to put the charge. Okay, no charge. No number. What do I mean by no number? For example, when you have sodium oxide, okay, so you will need 2 sodium ions to pair with an oxide ion. So many students will forget to put the 2 over here, so no number. And then the last very common error is that you didn't use a different symbol for the electrons gain. by the anion. For example, you will just put it as the same symbol over here. So you will recall oxygen is oxide ion is 2.8, and then you'll use the same symbol for all the electrons on oxygen. Then this is wrong also. Okay, so please remember, anions would have taken electron from another atom, so the electrons from the other atom needs to be represented with a different symbol.